Let h be the function defined by h of x equals f of g of x. Find h prime of 7. Here, f and g are twice differentiable functions. To compute the derivative of h prime, we need to use the chain rule. We'll take the derivative of f with respect to g multiplied by the derivative of g with respect to x. Now plugging in 7 into x, we get f prime of g of 7 multiplied by g prime of 7. Now using our table of values, we can substitute in some numbers here. G of 7 is 0, and f prime of 0 is 3/2, and multiplying that by the value of g prime of 7, which is 8, we get 12. So h prime of 7 is equal to 12. Part A finished. Part B, let k be a differentiable function such that k prime of x is equal to f of x squared times g of x. Is the graph of k concave up, concave down at this point x equals 4? In order to find out the concavity of k, we will have to calculate the second derivative. Here we're given the first derivative. So now we must take the derivative of this function. You see, if k is concave up, then the second derivative will be positive. If k is concave down, the second derivative will be negative. And so, taking the second derivative will allow us to know what the value is going to be. So k double prime is going to be found by doing 2 f of x, f prime of x times g of x, plus f of x squared times g prime of x. This is the product rule and the chain rule altogether. And plugging in x equals 4, we can use our table of values to evaluate for f of 4, f prime of 4, g of 4, f of 4 squared, and g prime of 4. Alright, so dropping in some values here, and calculating the results, k double prime appears to be, well, let's see, we get negative 72 plus 32. Well, it's clear that this is going to be negative. And using a little bit of math here, we finish this off and say k double prime of 4 is equal to negative 40. Therefore, k is concave down. When the second derivative is negative, the function is concave down. Part C says, let m be the function defined by m of x is equal to 5x cubed plus the integral from 0 to x of f prime of t dt. Find m of 2. Alright, so by direct substitution, 5 times 2 cubed plus the integral from 0 to 2 of f prime t dt. Okay, so what we can realize is that this is merely by the fundamental theorem of calculus, f of 2 minus f of 0 for the integral. So we get 40 plus, and using the table of values, 7 minus 10 gives us 37. So the value of m of 2 is 37. Last but not least is the function m defined in part C increasing, decreasing, or neither at x equals 2? So we plug in x equals 2. Well, no. First we have to find the first derivative of m in order to find out whether it is increasing or decreasing. You see, if the first derivative is positive, m of x is increasing. If the first derivative is negative, it is decreasing. So going through and differentiating, we get 15x squared plus f prime of x. And now m prime at 2 can be calculated to be 15 times 2 squared plus f prime of 2, which we can get from our table of values, which is negative 8. So now m prime of 2 is going to be the value we get by finding 60 minus 8, or 52. So m prime of 2 is 52. It's a positive quantity. We can then draw the conclusion that since it is positive, m is increasing at x equals 2. Well, that's it. I hope you liked this video. Please hit that like, subscribe, and notification bell for more videos, and thanks for watching.